Hi, welcome to another video podcast. This time we're going to look at the concept of the volt. It's a concept that when it was explained to you in school might well have been explained as the amount of push the electricity receives, but although that's true, it doesn't define what a volt is. Have a quick look at this circuit. We've got our battery, it's pushing electricity around the circuit, but what you'll notice is that I've tried to emphasize on here that this bulb is considerably brighter than this bulb. So the left bulb is brighter than the right bulb. But from our knowledge of current, it's a substance flowing around the circuit, and because this is a series circuit, we can be fairly certain, absolutely certain, that the current through both bulbs is exactly the same. So how is it then, if they're both receiving the same current, that one is brighter than the other? And the answer is, although the same amount of electricity is passing through both of them, they must be transferring different amount of energy for each coulomb that passes through. And that is the basis of the definition of a volt. So if we imagine this power supply being a 12 volt power supply, that means it supplies to each coulomb of electricity 12 joules of energy. If we put a voltmeter across this bulb, we can imagine it reading 10 volts, meaning that each coulomb of charge gives out 10 joules of energy in this bulb, leaving a further 2 joules of energy to be transferred out from this bulb. So 1 volt means 1 joule per coulomb of charge. And the difference between these two bulbs would have to be that the left-hand bulb, the brighter bulb, was a higher resistance bulb. Just to look at that in equation form, we'll do a little bit of just thinking about the logic of this. If we can imagine that in a circuit 100 coulombs of charge is transferred around the circuit, and the battery was a 12 volt battery, well, that means 12 volts means 12 joules per coulomb. So to each coulomb was given 12 joules. There are 100 coulombs. That means that there are 1,200 joules of energy transferred. Obviously, we must be able to write that as an equation. We can either write E for energy transferred is equal to QV. Sometimes you'll see it written as delta W, W meaning work, so the work done or the energy transferred is QV. It's also just worth seeing that from my first video podcast, the amp, we've got Q equals IT, so we can replace the Q here with the IT here, and we can then say that the energy or the work done in the circuit is equal to that well-known broadcaster ITV. Okay, thank you, and I hope you found that useful.